Hello everyone. Today let's discuss the operations of matrices. There are n number of matrices to be performed in matrices. So if we see, here is a list of operations to be performed. So if the list is addition and subtraction of matrices, multiplication of matrix by a scalar, multiplication of matrices, transpose of matrix, symmetric matrix, skew symmetric matrix. So let's solve the each and every operation individually. So let's start with addition and subtraction. So if we see addition and subtraction, the condition is for both addition and subtraction matrices, the condition is possible only when matrices are of same order. So the first condition is the two matrices should be of same order to perform addition or subtraction. So if we see here, a matrix A is of order 2 by 2 and another matrix B is of order 2 by 2. So the first condition is approved. And the second condition is the addition and subtraction occurs only between corresponding elements of A and B. So if we see here, let's start with addition. So if we add, so if we make addition between A and B, the addition will be equals to, addition is occurs between only corresponding elements. So the corresponding element of A, in A, the corresponding element of 11 is 7 in B. So between this, the addition will be equals to 17 plus 11 plus 7 will be 18. So 18, and 18 plus 3 is 21, and 6 plus 16 is 22, and 12 plus 4 is 16. So this is how the addition is performed. And next, if we see the same as subtraction, the process is same. It occurs between the corresponding elements. So if we see the corresponding element of 11 is 7. So the subtraction will be equals to 11 minus 7 is 4, and 18 minus 3 is 15, and 6 minus 16 is minus 10, and 12 minus 4 is 8. So this is how addition and subtraction are performed. So if we go with the next one, there is multiplication of matrix by a scalar. So what is multiplication of matrix by a scalar? If every element of A is multiplied by a scalar k, so when every element of A is multiplied by a scalar k, then it is said to be multiplication by a scalar. So here if you see an example, A matrix is multiplied with k, so it became, so 1, 2, 3, 4 became k, 2k, 3k and 4k. So each element is multiplied with k, and the matrix obtained by k times of matrix A. So this is saying that the matrix obtained is k times of A. It means equals to k times of A. So here it is same. So if you see an example, another matrix A is equals to 5, 6, 7, 8, 9, 10. So what is the value of 3A? So the process is, we should multiply the each and every individual element with 3. So the answer will be equals to, so 3 times of 5 is 3 5s are 15, 3 5s are 15, and 6 3s are 18, 21, 7 3s are 21, and 8 3s are 24, and 9 3s are 27, and 10 3s are 30. So this is how multiplication of a matrix by a scalar is performed. And in the same way, next if we go with the multiplication of matrices, so this is somehow different from multiplication of matrix by a scalar. This is occurred between two matrices can be multiplied only when number of columns in first is equal to number of rows in second. So as we know that number of columns is n and number of rows is m. So the condition is number of columns in A is equals to number of rows in B. So when this condition is approved, when number of columns in A is equals to number of rows in B, the multiplication of matrices can be performed. So let's start. So the first, there are number of rows are 3 rows and in A, and number of columns are 3 columns in B. So number of rows in A is equal to number of columns in B. The multiplication can be performed. So if we see that first row into first column of B, so the multiplication will be 7 into 4 and 8 into 7. So the answer will be 7 4s are 28, and next 8 7s are 56. In the same way, and second row into second column, 9 5s are 45 and 8 6 are 48. And next third row into third column, 4 6 are 24 and 2 9s are 18. So the first row into first column and second row into second column and third row into third column is performed. This is how multiplication of matrices is performed. Next, if we go with the next case, transpose of matrix. So transpose of matrix means it is very simple. It means it is denoted by a power t or a dash. So the condition is matrix obtained from interchanging rows and columns of a given matrix A is said to be a transpose of A. So if you see that when a matrix A is equals to 1 5 0 and 3 4 7, the number of rows are 2 and number of columns are 3. It means the order is m by n. So when number of rows are interchanged to number of columns, that is said to be transpose of A. So if we see that the order is m by n, so the transpose of A will become row got changed into column. So 150 row is converted into 150 column, and 347 row converted into 347 column. So the order got changed. M by n is changed to n by m. So this is called as transpose of a matrix. So the interchange of rows and columns is said to be transpose of a matrix. Next, symmetric and skew symmetric matrix. The symmetric and skew symmetric matrix is a very simpler one. So symmetric means when a matrix is so when transpose of A is equals to A, it is said to be a symmetric matrix, and when transpose of a matrix A is equals to minus A of A, it is a skew symmetric matrix. So if we see an example, A is equals to A, H and G. So if we make the transpose of A, it will be equals to, so AH row will become converted into AH column, and HG row will converted into HG column. So but the output is same. It is converted into A itself. So the transpose of A is converted into A itself. So it is said to be a symmetric matrix. When transpose of A is equals to A, it is said to be a symmetric matrix. In the same way, if we see the skew symmetric matrix, there is an example. A is equals to 0, I, minus I and 0. So if we make the transpose of A, it will be equals to 0i row will be converted into 0i column, and minus I 0 is row is converted into minus I 0 column. So here what is done, the negative sign got interchanged, so the output is got it as minus A. So it is said to be a skew symmetric matrix when A transpose is equals to minus of A. So if you see here, the minus got changed to this element. So this change is called as denoted by skew symmetric matrix when A transpose is equals to minus of A. So these are the operations of matrices. Thank you.